Okay, so I'll begin from the beginning now. So I was saying that we will do the revision of the previous sessions, which you would have understand in the lecture, the various form of differential equations. So the one is exact differential equations. So let's say if an equation is given in the form n dx plus n dy equals to 0, then you check for its exactness. This is the condition, dou m over dou y equals to dou m over dou x. And if the equation is exact, the general solution is given by this particular equation, that is integral of n dx plus integral of n dy. And in the n, x is replaced by x naught. Now, the non-differential equations are those which do not fulfill this criteria for exactness, that is dou m over dou y is not equal to dou n over dou x. So, to convert these non-exact differential equations to the exact differential equations, we take the help of something called as integrating factor. So, let's say the integrating factor is of the form u xy. This is a function. So if we multiply this integrating factor to the entire given differential equation, the equation will become exact. So this has already been shown in the lectures how to do it. So the condition which we get, just for the sake of revision, I'll write it down. In ux would mean partial differential of u with respect to x minus n uy equals to u n y minus n x, right? So this is a partial differential equation, and by solving this we can get the integrating factor. Now there were some simplified cases which were talked about in the lectures, such as, let's say, when this dou m over dou y minus dou m over dou x over n is equals to a function of x, only a function of x. In this case, you can directly write your integrating factor as u equals to some constant exponential integral of this function of x. Similarly, we can check if we can get this integrating factor as a function of y only. So for that, what we can do is if this comes out to be a function of y only, then simply the integrating factor can be written as some constant integral of phi by dy. Alright? Okay. Now for general cases also, several cases have been taught in the lecture, but for now, let's do some sample problems to understand these. Okay. Consider an equation x square plus y square plus 5 dx minus 2x5 dy equals 0. Now, first check whether this equation is exact or not. Can you guys check and let me know? So we need to check dou m over dou y is equal to dou n over dou x or not. So what is n here? It's x square plus y square plus 5. So what will this be? 2y, right? And n is minus 2xy del n over del x will be minus 2y. Yeah. So clearly from this what we can say is that dou m over dou y is not equal to dou n over dou x. That means this differential equation is non-exact. Now how do we go about solving it? Would somebody like to respond? Simply by multiplying it with an integrating factor. Now our first task is to find that integrating factor. Okay, so let's see what the integrating factor will be. What this becomes? 2y minus of 2y, which is equals to 4y. Now shall I divide it by n, which is this, or minus n? So if you see carefully, if I divide by this term n, then it will become a function of x only. So let's divide it by n. Then this becomes 4y over minus 2xy, which is minus 2 over x, and this is a function of x only. So what will be the integrating factor in this case? So mu x can be written as e to the power integral of yx dx, which is e to the power integral of minus 2yx dx. Okay. So this will become e to the power minus 2 log of x, and then so the integrating factor in this case comes out to be 1 by x square. Okay, so if you multiply this given differential equation with this integrating factor, what the equation will become is x5 2x minus 2x5 dx. Okay. Now if you check, this equation is exact differential equation. You can check it on your own. So these are, now this entire term will be n, and this entire term will be n, and the solution for the exact differential equation will be integral n dx, where we will treat y as constant, plus integral of terms of n not containing x. dy equals to some constant. Right. let's do it. This will become 1 by x square plus y square plus 5 dx minus integral of 2y over x dy goes to some constant. So this will be some 1 plus y square over x square. So you can club these two terms. The integral of 1 by x square will be minus 1 by x, and we need not consider this term as it contains x. So this simply directly can be written as constant. So the solution will be x minus 1 by x y square plus 5 equals to constant. Okay. Any questions in this? Before we move on to the next question, please let me know if you have any questions. Okay, looks like there are no questions. So let's consider another question. Okay, so we have to solve this equation. Again, this is n, this is n. So dou m over dou y, what will it be? 0. So this will be 4y cube plus 2, and dou n over dou x, this is y cube minus 4. So clearly the given equation is not exact. Now to convert it to exact differential equation, let's see what the dou m over dou y minus dou n over dou x will be. So this is 4y cube plus 2 minus y cube minus 4, and it becomes 3y cube plus 6. Right? Now what will happen if I divide it with n? So if you see clearly, n is y to the power 4 plus 2y. So if you take y as common, this will be y cube plus 2, and this difference can be written as 3 common y3 plus 2. So we can divide this with minus n, and what we will get is 3 y3 plus 2 over minus y3 plus 2. This gets cancelled, and this is minus 3 over 5, and this is a function of y only. So the integrating factor can be written as mu y equals to exponential of 5y dy. This will be y2. So the integrating factor for this comes out to be 1 over y cube. Now multiply the given differential equation with this integrating factor on both sides, and this equation shall become exact differential equation. So if we do so, this is now 1 by y cube multiplied with 1 by y cube. So this will become y to the power 4 plus 2y dx plus 1 by y cube x y cube plus 2 by 4 minus 4x dy equals to 0. Now this is your mu m and this is your mu n, and you can solve this equation because this is now exact differential equation. So the general solution will be integral of m dx plus integral of m dy equals to some constant. So this will be y plus 2 over y square dx plus integral of x plus 2y, and to these terms which contains x we need not consider. As to constant. The solution will be xy plus 2x over y squared plus y squared equals to constant. So this is the solution for this exact differential equation. Any doubts till this point? Okay, if not, then we will move to the other problem, which is linear first order differential equations which are of this form: dy by dx plus some function of x into y equals to some other function of x, and we are given some initial condition, that is y at x0 equals to y0. Now for this integrating factor, mu x can directly be written as exponential of integral dx, right? So, and the solution is given by y into this mu x equals to integral of gx into mu x plus constant. So this is the general solution. So now let's solve this question where it is given that the solution of 1 plus x square y prime plus 2xy equals to 2x with initial value y0 equals to 0. What will it be? So let's write this 1 plus x square dy by dx plus 2xy equals to 2x. Now let's try to bring it into the standard form of a linear first order differential equation, because this is first order differential equation. So dy by dx plus this will be 2x over 1 plus x square into y equals to 2x over 1 plus x square. Now if you compare it with the standard form, you can simply see that this forms the function dx and this forms the function gx, right? So what dx is 2x over 1 plus x square. So integrating factor will be exponential to the power px dx. This will become integral of 2x over 1 plus x square dx. Now this can be written as integral of, so this exponential of this integral. In this integral, let's say if you take 1 plus x square as some t, you will have 2x dx equals to dt. So this integral will become dt over t, which is log of t. So this will be simply log of 1 plus x square. Right? So the integrating factor mu x becomes 1 plus x square. Okay. Now multiply with integrating factor on both sides, and this equation can then be solved. So the solution we already know is will be of this form. So let's directly write the solution. So this will be y into 1 plus x square equals to integral of this term gx, which is 2x over 1 plus x square into integral factor plus some constant. So this cancels. So this will become x square plus c, and this is y into 1 plus x square. So y will become x square plus c over 1 plus x square. Now we are also given the initial condition. Initial condition is y of 0 equals to 0. So this implies that if we put x equals to 0, then y is 0. So this is c over 1, which means that c equals to 0. So the answer is y equals to x square and 1 plus x square. Right? So this will be our correct option. Any doubt? Yes, previous solution was also general solution. So without, if we are not given any conditions, initial conditions, then all the solution will come out to be general solutions only. That's what we have learned in the course so far. Okay, so now let's solve another problem. Solve the initial value problem. Which is y dash plus y tan x equals to sin 2x. And initial condition given is that y at x equals to 0 is 1. Okay. How do we go about it? Now we know that standard form of linear first order differential equation is y dash plus pxy equals to qx, right? So in this case px is 10x and qx or gx will be sin 2x, right? So integrating factor will be mu x, integrating factor, this will be exponential of px dx, right? So we will require integral of 10x, which becomes e to the power ln sec x, and this is what is our integrating factor. Now the general solution will be y into this integrating factor qx equals to integral of this gx mu x dx plus c, right? So this becomes y into sec x, this will be sin 2x into sec x dx plus some other constant, some integration constant c. So y will be 1 by cos x sec x will be 1 by cos x, so that's why this is not cos x. Integral of sin 2x, sin 2x can be written as 2 sin x cos x, and sec x can be written as 1 by cos x. Cos x cancels out, and what we have is cos x integral of 2 sin x dx. So this becomes minus 2 cos x plus c. Right? So this is the solution. Now let's apply the initial value condition, which is y of 0 is 1. So 1 equals to cos of 0 is 1 minus 2 cos 0 is again 1 plus c, and this is the constant to be 3. Okay, so the solution becomes y equals to cos x minus 2 cos x plus 3. Is it clear till this point? Any questions? other thing which was taught in the lecture was when the given equation is not linear and we reduce it to the linear equation form. So one example which was given in the lectures was the Bernoulli equations. Right? Now let's say if an equation is given in the form dy by dx plus ax into y equals to 2x y to the power alpha, where alpha belongs to the real domain. Now how do we proceed to solve this equation is first we divide this equation by y to the power alpha, and then in the lecture it was shown when we divide it becomes y to the power minus dy by dx plus px y to the power 1 minus alpha equals to qx, right? And then let z equals to y to the power 1 minus alpha, then this dz over dx will become 1 minus alpha y to the power minus alpha dy by dx. So when you do this and substitute, make this substitution of z equals to y to the power minus 1 minus alpha, then this equation takes the form dz over dx plus 1 minus alpha px into z equals to 1 minus alpha qx. And this is now the linear first order. This is your now modified px and this is a modified qx. Okay. So shall we? Okay. So there's a question by Ravi Shankar that will we not consider the mod while integrating? Yes, you have to consider the mod while integrating, but given in the domain, if that mod is not required, that if it is the value inside the mod is always positive, then you can just simply release the mod. And since we are talking about the real domain, in most of the cases we will be directly able to release the mod. Like mod sec x was there, we can directly write it as sec x in the given domain. Unless it is specified in the question that this is the particular range, let's say it's given that -3 to 3 is where x lies, then only we have to worry about the sign of the mod. Otherwise, we can simply, if possible, just carry it along. Otherwise, we can simply ignore it. Okay. Is it clear? Okay. So now let's move on to another problem. So there is something called as logistic equation. Which is of the form y dash equals to ay minus by square, where a and b are the constants. Now you have to solve this equation. So is it linear? No, right? So first we have to do this exercise which we did with the Bernoulli's equation. So basically this logistic equation is a form of Bernoulli equation. It's a Bernoulli equation. So we will do this exercise. Now we simply know that we can substitute z as y to the power 1 minus alpha. So here if you see, here let's write it in the familiar form, which is this minus by square. So here alpha is 2 by this one. This is what is alpha. So the substitution which you will have to make is y to the power 1 minus alpha. So this will be y 1 minus 2 therefore 1 by 1. Okay. So now dz over dx will be simply this d by dx of 1 by y, which is minus 1 by y square dy by dx. Okay. So substitute in the above given equation and let's try to solve it. So in this equation, so this will become from y dash from here to be minus y square dz over dx minus ay equals to minus by square. Now divide this entire equation by y square. This will become minus dz over dx minus a over y equals to minus b. Now you see here this term minus 1 by y can be written as minus a. So the equation will become minus dz over dx plus minus z equals to minus b. Let's cancel the minus from the parts. So the equation which we are now left with is this dz over dx plus az is equals to b. Now this is the familiar equation, right? Where px equals to a and gx equals to a. Okay, so this once it is reduced to this familiar form, linear first order differential equation, we can simply find its solution. So the first step would be to find the integrating factor, which is in this case will be this is px dx, so this will become e to the power simply a dx e to the power ax, right? Now this general solution will be z into e to the power ax equals to integral of e to the power ax plus some constant c. Right? This is what we have, right? Okay. So this will be b is constant, integral of e to the power ax will be, we have ax over a plus c, and then z can be written as b over a plus c e to the power minus ax. Right? So now what is z? Z is 1 by 1. Therefore, y can be written as 1 over c e to the power minus ax plus e by a. So this will be the solution of this particular equation. So let's solve the equation. Let's solve. Is my screen visible now? Great. Sorry, I lost connection for a while. Yeah. So now let's try to solve another question. So consider a question which is y dash cos square x plus 3y plus 2y, and we are given that y of pi by 4 is equals to 4 by 3. So you guys want to give it a try to solve this question and let me know in comments if what kind of equation is this first. Okay, so my screen is not visible to you guys. Okay. Is it visible now? Sorry, I lost connection for a while. Okay. So let's try to solve this question. Y dash cos square x plus 3y is 1, and this is the initial condition which we are given, that y of pi by 4 is equal to 4 by 3. So we can write it as, so first let's divide this entire equation by cos square x. So this will become y dash plus 3 by cos square x, y equals to 1 by cos square x. Now this is the familiar form, right, where this function is px and this function will be qx or gx, any nomenclature. So the integrating factor mu of x, what will it be? E to the power integral of px dx, and that becomes integral of 3 by cos square x dx. Right? So this is e to the power 3 integral of sec square x dx, and this will become e to the power 3 10x. This is your integrating factor. So the solution of this first order linear differential equation can be written as y into e to the power 3 10x equals to integral e to the power 3 10x into function gx, which is 1 by cos square x. 1 by cos square x dx plus integration constant. Now you have to solve this integral. So how to solve this integral? Any hints? I'll tell you then. So let us consider this 3 10x equals to t. then differentiate, that will be 3 sec square x dx equals to dt. So dx over cos square x can be written as dt over 3, right? So what will this general solution become now? Y into e to the power 3 10x equals to integral of 1 by 3 e to the power t dt plus c, right? So this will simply be e to the power t over 3 plus c and e to the power minus 3 times y. Right? So this is the solution. Now we have to substitute back the value of t. So this will be e to the power 3 times over 3 plus c into e to the power minus 3 times. Now y becomes 1 by 3 plus c e to the power minus 3 times. Now in this equation, we now have to find the value of this constant. For this, we are given the initial condition, which is y of pi by 4 is equal to 4 by 3. Now if you put this initial condition, you will get the value of the constant. So this will be 4 by 3 equals to 1 by 3 plus c e to the power minus 3 10 pi by 4 f is 1. So c comes out to be e cube, right? So the solution will be 1 by 3 plus e to the power 3 minus 3 10x. Okay, so any doubts till this point? If not, then we will do a very simple question now related to the Wronskian. Okay, so the question is, you have to show that x1, okay, is this what you want? I love the question. So the question is, you have to show that x1 of t equals to and so you have to show that these have a non-zero Wronskian for all t. Provided alpha is not equal to beta. Okay. Okay. So how have you defined the Wronskian in the lecture? If y1 and y2 are two solutions, then the Wronskian will be y1 y2 dash minus y2 y1 dash, right? That is the determinant. Okay, so in this case, what will the Wronskian will be? So Wronskian will be x1 x2 dash minus x2 x1 dash. So x1 is e to the power alpha t, x2 prime will be beta power beta t, right? And x2 is e to the power beta t, and x1 prime will be alpha into e to the power alpha t. Now if you take e to the power alpha plus beta t as common, you will get beta minus alpha, right? So since alpha is not equal to beta, this means that beta minus alpha will be a non-zero quantity. So this means that Wronskian is non-zero. So this is what we have to show in this question. Any doubts? Okay, if not, we will solve one more question. So the question is y prime sine 2y plus x cos 2y equals to 2x. Okay? So you have to solve this equation and find a general solution for this. Now let's try to bring it to the standard form. So we will divide it by sine 2y. This becomes y prime plus cos 2y over sine 2y x equals to 2x over sine 2y. So this is clearly not linear differential equation, right? Right? So let's see how can we solve it. So let consider z equals to cos 2y. So dz over dx will be, if you differentiate it with respect to x, will be minus 2 sine 2y dy by dx, right? So dy by dx can be written as y prime. So this will become sine 2y y prime is equal to minus 1 by 2 dz over dx. Okay, so this is the last question which we will solve for today. Right? Now you have to substitute this in the given equation. What that equation becomes? So if you substitute it in this equation, this will become minus 1 by 2 dz over dx plus x cos 2y can be written as z equals to 2x. Okay. So this is dz over dx minus x z minus 2x equals to 4x. Okay. So this is now your linear differential equation where this term is of px and this term is of qx. So integrating factor ux will be now e to the power integral px dx. So this becomes e to the power integral of minus 2x dx, which is e to the power minus x2. So this is your integration factor in this particular problem. So now the general solution can be written as z into mu x equals to integral of this minus 4x into mu x dx plus constant. So this z is e to the power minus x square. If I take it on the other side, what will this be? Z equal, sorry, mu x is this e to the power minus x square. So z will become e to the power x square, and then this will be integral of minus 4x e to the power minus x square dx plus c. Now you can solve this integral. How? Let consider minus x square equals to some t, then minus 2x dx will be dt, right? So this integral will become z equals to e to the power x square 2 times 2x dx and substituting as dt, and e to the power minus x square is et plus some constant. So this will be e to the power x square into 2 e to the power t plus c, and this side will become e to the power x square to e to the power minus x square plus c. If you open the brackets, it will be 2 plus c e to the power x square. So this is your solution. Now in this we have to substitute for z. What we are choosing? Z. So z we have taken as cos 2y. So the solution will be cos 2y equals to 2 plus c into e to the power x square. So this is the solution, but it is in implicit form. So this is your final solution. Now if you want to further write it, simplify it and write it in the explicit form, you can write it as 2y equals to cos 2 plus c e to the power x square, and then y will be 1 by 2 power cos 2 plus c e to the power x square. Right? So this is your general solution in explicit form. So explicit form is basically where you are able to write something as clearly y as some function of x. It's not like this where some function of y is equal to some function of x. Now there is another way by which we can solve this equation, and that probably might give you a simpler answer. See, this seems to be a very complex solution. So for that, let's see how to proceed. Second method, that is by separation of variables, the very first technique which we have learned. So if you write it as, so this is the given differential equation, y prime sin 2y plus x cos 2y equals to 2x, and you just rearrange, and what you will get is y prime sin 2y is equal to 2x minus x cos 2y. So you can see simply that write y prime is dy by dx, and now you can use separation of variables here. Right? So if you use separation of variables, what this will become? dy by dx will be, if you take x common, this is 1 minus cos 2y over sin 2y. So this will be sin 2y over 2 minus cos 2y dy equals to x dx. Now we can integrate this. So to solve this, you can take 2 minus cos 2y as some constant t. This will give you sin 2y equals to dt. So this integration, it will become ln 2 minus cos 2y equals to x square plus c. So this is another solution, another way of writing the solution for this particular equation. So this is also general solution. Any doubts? Okay, if not, then we will close today's session. So thank you for joining us and see you next Friday at 6 p.m. Bye.